problem also. So today we are going to study the orbital. Okay. So earlier time that
Yes,
is
sir.
earlier time it was supposed that the electrons are revolving on the circular path. But nowadays in the when you talk about the modern concept, so there is what the electron, how the electron is present. They are not in the orbital. What they are talking about? It is three-dimensional space. They are talking about it is three-dimensional space. Three-dimensional space where what is this they are talking about, where probability of finding electron is maximum. Probability of finding electron is maximum. Finding electron is maximum. So if you talk about the orbital, it is the probability of finding the electron. Now you see that is they are the four types of orbitals are there. Let us try to understand types of orbital. Okay. So if you talk about types of orbital, the first one is the s orbital. We are going to describe s orbital is there, and then we are having the second one is the p orbital. P orbital. The third one is if you talk about the d orbital. Okay. And the last one, the fourth one is f orbital. They are the four types of orbitals are there where the probability of finding electron is maximum. That is, the electron are present in this orbital. Let us try to understand the s orbital. If you talk about the s orbital here.
Yes, sir.
So s orbital means it is a spherical shape. They are talking about it is spherical shape. Its shape is spherical shape and is only one type and is only one type and is only one types and have what they have and have maximum. How many are maximum? 2 electron. Maximum 2 electron. One type means one orbital, so 2 electron. How? It is spherical shape, you can see. So here is the spherical shape. This is the spherical shape. Okay. Or how can you draw? This is the center. So around the center you can draw like that. Here. It is the probability. You cannot have the solid line. It is the probable line. Okay. This is the diffuse, dotted line. Means these the dotted are representing the electron can be present here and there. These are the spherical shape. Here electron is possible. Okay. So this is the figure. Spherical shape of s orbital. Spherical shape of s orbital. Shape of s orbital. Now if you talk about how many electrons are there, so s orbital, if you see only one type is there, so maximum electron how many are there? 2. One orbital, maximum electron how many are there? Maximum electron is equal to 2. Is it okay?
Yes, sir.
For one electron, they are talking about for one electron represent, how they are going to represent for one electron represent S1. For two electron represent, how can you represent? Because only 2 electron is possible, so S2. Got it?
Yes, sir.
Next one is there. We are going for the P
Sir,
orbital.
wait second back.
Okay.
1 minute, sir. I'm writing.
This one.
1 minute.
This one.
No. After that one.
Okay.
I saw orbital.
Vivisan called you.
No, sir.
Okay, he said that is today I will call her, like that he said.
Okay, sir. No, sir. He did not call. He did not call me or my father.
Okay.
Done, sir.
Okay. Now we are going for the p orbital. See the p orbital. If you talk about p orbital, so it is dumbbell shape. It is dumbbell shape.
Dumbbell.
Dumbbell shape. You can write dumbbell shape. Okay, dumbbell shape. Or okay, this is dumbbell shape. Dumbbell means either you can say what the people are using the that is for exercise. Dumbbell, that is, it is a dumbbell shape. And they are talking and are of three types. Total are of three types. Now you know that is one orbital, two electron, one orbital, two electron. Okay, so they are the three types, means three orbital, na? They are three types. So it is dumbbell shape and are three types. So they have what they are talking about. They have how many maximum electron if you talk about. So maximum electrons. So three types are there. One type means two electrons. So three type means they have maximum 6 electron. Okay. Now you see
Yes, sir.
dumbbell shape if you are making. So the first dumbbell is like that. This is the dumbbell. Okay. Since it is on the x-axis, so its name is going to be px. Here is if you talk about another one. So another one is orbital is there on the y-axis. This is the y-axis. So its name is going to be py. And last one, if you talk about the z-axis, so it is going to be pz. Here is, so it is the z-axis, so it is going to be pz. Now see, now how can you represent these orbital? These orbital are three types. So I am making. So first one is going to be px. This is py or pz. One orbital is having the two electrons, so it is 1, 2. This is 3. Here is 4. This is 5, and here is 6. So total 6 electron. 6 electron.
Yes, sir.
Total 6 electron in p orbital. P orbital. This is the concept for p orbital. Now we'll go for the d orbital.
Sir, this comes under this atomic structure only.
Yes. Electron, proton,
Okay.
neutron, filling of electron, they will come under the atomic structure.
Okay, sir.
Very soon we will finish.
Because, sir, this we studied in chemical bonding in college. And you also taught me in chemical bonding.
This is required for chemical bonding.
Yes.
But little bit you study electronic configuration. Otherwise, it may create the confusion. Little bit you study. Very short way I am teaching you.
Yes.
Is it done? Is it done?
1 minute, sir. 1 minute, please.
You have very sharp memory. You know when what
Yes,
is
sir.
taught. You have very sharp memory. You know when is what taught.
Yes, sir. Yeah, done, sir.
Okay. Now we are going for the d orbital. Let's go for the d orbital. If you talk about the d orbital, so this is the it is double dumbbell shape. It is they are talking double dumbbell shape. Dumbbell shape. Dumbbell shape, and are how many type? And are 5 types. And are 5 types, and have maximum, how many electron can be the maximum, and have maximum 10 electrons, which are, they are talking about, what are they, which are, if you talk about dxy comma dyz comma dzx comma dx square minus y square, and last one is dz square. So they are there. So let us try to understand one by one. How can you be? If you talk about dxy, so orbital will be between the x and y. So here is x, this is y. So I am making the lobes here, double, one dumbbell and another dumbbell. So dxy, this is the dxy. Now, if you're talking about dyz, okay, dyz. So this you consider y and this you consider z. So let us try to draw it out. So here is the yz, and here is also the last one. You see the last one. What is there? Zx, zx. So here is the orbital is, this is the between the zx. This is there. Now the last one is x square minus y square. So this is x and y. So square is there. So half will be the on this x axis and another will be the y axis, right? This one. And the last one is dz. Here is the z. Okay. So orbital will be on the z axis and there will be the circle on the center. Now, if you name it this one between the y and z, so its name will be between y, z. Between z and x, so its name will be dzx. On the x and y, so dx square minus y square. On the z, so that is dz square. Total 5 orbitals, so it is going to be how many electron? That is 10 electron. You can make it like that. So here is 1, this is the 2, here is 3, and this is 4. So it is going to be dxy, this is the dyz, dzx, dx square minus y square, and dz square. Let us fill the electron. Here is 1 electron, 2, 3, 4, 5. Then pair it. 6, 7, 8. Here is 9, and this is going to be 10. So total electron in the d orbital is 10 electron. Got it?
Yes, sir. Okay, sir. Wait, sir. I'm noting it down. Please wait.
Okay.
Done, sir.
Okay. Now we are going for the another type, that is f orbital. Okay. Let us try to write down the f orbital. So if you talk about the f orbital, it is of diffuse shape. It is having what is having, it is having diffuse shape, it is having diffused shape, right? Now if it is having diffused shape, then what you can draw the conclusion from it, it is having the diffuse shape, that is it cannot be drawn on paper, it cannot be drawn, okay, drawn on paper, you can't draw on paper, okay, and are of following 7 types, following how many types, 7 types, that is they have, one type means 2 electrons, so 7 type means 14 electron, that is they have maximum 14 electron, they have maximum how many electron, 14 electron, they have maximum 14 electrons. Now let us try to understand. So total 14 electron we have to write like that, 1 2 3 4 5 6 7. So 1, this is 2 3 4 5 6 7, then here is 8 9 10 11 12 13 and 14, so 14 electron in f orbital. Okay, so please write down this one also.
Yes, sir. Mm.
Done.
Yes, sir. Done.
Okay, now let us go with the next one, filling of electron, f double e, no, f I double l I, filling of electron in one orbital, in orbitals, okay, filling of electron in orbitals. So how we fill, according to Abau rule, AUFBAU, Abau rule, we have to fill according to Abau rule. Okay, what is the Abau rule? Electrons are filled, they are talking about electrons are filled, electrons are filled in how, increasing order of, they are talking about electrons are filled in increasing order of energy of orbital, increasing order of energy of orbital, you need to fill the electron in increasing order of energy of orbitals. Okay, That is, okay. Firstly, the 1s orbital, then 2s orbital, then 2p orbital, then 3s orbital, then 3p orbital, then 4s orbital, then 3d orbital. So they are what that is. This is the order of what they are talking about. Order of increasing energy of orbital. Order of increasing energy of orbital. Got it? Increasing energy of orbitals. Here, if you talk about the s orbital, if there is there s orbital, so that is s1 to s2. It can be p orbital. It can be p1 to p6. Anything. D orbital is there. It will be d1 to d6, and f orbital it will be there f1 to f6, f14. It is the 10. So they how we have to fill. So firstly, you write down this one. So we will go for the examples.
Yes, sir. Okay.
Done.
Yes, sir.
So I'm erasing this one. Can I erase?
Yes.
Okay. So I'm writing here elements. Here I'm writing electronic configuration. Electronic configuration. Electronic configuration. If you talk about electronic configuration, means what they are talking about, filling of electron. This is what filling of electrons. This is. So let us try to understand this one. Here, if you talk about the hydrogen, then we'll go helium, then lithium, then sodium, lithium. After lithium, it is beryllium. Okay, let us try to go beryllium, then boron, carbon, nitrogen, oxygen. Here atomic number 1, this is 2, 3, 4, 5, 6, 7, 8. So atomic number is equal to number of electron. Okay. So one electron is there. If I am writing, here is total electron. If you see here, if I am writing total electron, so how many electron are there? 1, 2, this is 3, here is 4, 5, 6, 7, and 8. So what will be the configuration? Can you please tell me, Janab, for hydrogen? Hello.
Yes, sir.
What will be the configuration of hydrogen?
1.
1. That is okay. In orbital, which orbital? 1s1. Getting?
1s1.
Huh.
Sir, this is just for electron configuration.
What about this one? Helium.
1s2.
Thank you. 1s2. Lithium.
Lithium 1s1. 1s2.
Then see here. After 1s,
1p.
no. After
2s.
1s, it is 2s, na? So it is going to be
Yes,
where?
sir.
2s1. So total electron 2 plus 1, that is 3. Now you go for the beryllium. Okay. Tell me for the beryllium. Tell me. For
1s2, 2s2.
Thank you. 1s2 and 2s2. Okay. Now come for the boron. Yeah. Tell me. Come boron.
Boron. It's 1s2, 2s2. 1s2, 2s2, 1p.
No.
2p.
Yeah. 2p. 2p, 1.
1.
Okay. Now go for the carbon. Let us see for the carbon and nitrogen. Tell me for the carbon. Janab.
Carbon, sir. 1s2, 2s2, 2p2.
Thank you so much. 1s2, 2s2, and 2p2. Come for the nitrogen. It is going to be 1s2, then 2s2. P orbital can have the maximum 6 electrons, so it can be 2p3. Oxygen 1s2, then it is going to be 2s2, and last one is 2p4. Can you understand this?
Yes, sir.
Okay, write down please. Done. The last page you
Yes,
wrote,
sir.
the last page, this page you wrote now, this one.
Yes.
Okay. Can I erase this one?
Yes.
Okay. So now we are going for the, this is the configuration is over already. Once I taught, again I taught. Let us go for the another concept, de Broglie concept. De Broglie concept. PRO. De Broglie concept. Okay. So what the concept they are saying de Broglie. Okay. What the concept they are saying, that is a small moving particle, okay, small moving particles have, small moving particles have two property, two property, two property. What is property? That is, they are talking about, that is, they act as a particle, and also as a wave, as a wave. And this property of the, and they are talking about, and this property, and this property is known as what? And this property is known as, what is going to be known? This property is known as dual nature of electron. Dual nature of electron means, dual nature of electron means, that is, electron is having two properties. What is? The first one is the particle nature, and second one is that is called wave nature. Okay, how can you define this one? So lambda is equal to h by mv. Okay, this is the equation they have given. Okay, now what is that is lambda? If we talk about lambda, wavelength, this lambda is wavelength, right? H is equal to, that is called Planck constant, Planck, Planck constant. Okay, Planck constant, its value is 6.626 into 10 power minus 34 joule second. Okay, minus 34 joule second. That okay. Now m is equal to mass of electron, mass of electron, mass of going to be electron. B is equal to velocity of electron, velocity of electron. This is there.
Yes, sir.
This you write, please, so that we will go for the problems based on it. Done?
Yes, sir. 1 minute.
Okay.
Done, sir.
Okay. So, see, this is with the other formula is being supposed to be. See, momentum is equal to what? If you study MOMENT, momentum. So this is momentum means product of mass and velocity. Product of mass and velocity. Mass and velocity. This is what the momentum is all about. So that is momentum is represented by P. And product of mass means M, velocity is V. So from this equation, what can we write? So from what we can write? So from de Broglie equation. So from de Broglie equation. So from de Broglie equation, what is this? P is equal to, okay, H by mb is there. No. Lambda is equal to H by mb is there. So at the place of mb, what we can write? So lambda is equal to, it can be H by P. Okay, lambda is equal
Yes, sir.
to P is what is momentum. That is the physics term. P is momentum.